Welcome to Spring LIB.
In this exercise, we're going to be dealing with inclined planes. So before explaining the exercise, let us first review how we should deal with an inclined plane. So consider that we have a block that's lying in an inclined plane. Okay, the plane makes an angle of theta with the horizontal. The block has a mass m. Okay, and let's say that our goal is to find the acceleration of the block. What should we do in order to do that? Well, this here is the block and has a mass m. Let's draw a free body diagram of the block. The forces that act on the block are the gravitational force that acts downward and has a magnitude of mg, the normal force that is perpendicular to the surface, and the friction force that points opposite to the direction of motion of the block. Now, the gravitational force, mg, can be decomposed into a component that is perpendicular to the plane and a component that is parallel to the plane. Okay, so this here is theta, this is mg, and we have fy and fx. And here I've set up a coordinate system such that the y-axis points perpendicularly to the plane and upwards, and the x-axis points down along the plane. Okay, so we have that fy is equal to mg cosine of theta, while fx is mg sine of theta. So we have all the forces that act on the block, and we should be able to find what is the value of the acceleration. So let's start with the y component. In the y component, we have the normal force pointing upwards and the y force pointing downwards, which is mg cosine theta. And the block is not moving in the y direction, so this is equal to 0, which means that the normal force is mg times cosine of theta. In the x-axis, we have mg sine theta, the fx force pointing along the x direction, minus the friction force. And this is equal to the mass of the block times the acceleration. Now remember that the friction force, Ff, is equal to the coefficient of kinetic friction, mu k, times the normal force. So this is mu k mg cosine theta. So in our equation, we're left with mg sine theta minus mu k cosine theta, and this is equal to ma. So the m's cancel out. We have a g sine theta minus mu k cosine theta is equal to a. So this is the acceleration. Okay, and this ends our review of the inclined plane, and we have all the information we need in order to solve our problem. So in our problem, we have a block that has a mass of 12 kilograms sliding down the plane with an initial speed of 2.5 meters per second. And we have that the coefficient of kinetic friction between the surface and the block is 0.3. The incline has a length of 3 meters. Our goal is to find what is the minimum value. Actually, this shouldn't be 30. I'm sorry for that. This should be a generic theta. So sorry. So we have to find what is the minimum value of the angle theta that the incline makes with the horizontal, such that the the block will be able to reach the bottom of the incline. Okay, so basically what I'm going to do first is to use Torricelli's formula. So we have that v squared is equal to v0 squared plus 2 times the acceleration times delta x. Okay. And I'm gonna try to isolate the acceleration a and find which acceleration the block must have, so that what is the maximum acceleration actually that the block must have for it to reach the bottom of the incline with at least a null speed, that is v equals 0 after delta x equals 3 meters. Okay, hopefully we will have v greater than 0, but we are calculating the limit situation. So we have 0 is equal to v0 squared plus 2a delta x. Okay, so we have that v0 squared, actually, I'm sorry, minus 2 v0 squared divided by 2 delta x is equal to the acceleration a. So we have that this is equal to, as we found before, g times the sine of theta minus mu k times cosine of theta. So we want sine of theta minus mu k, which is 0.3 times cosine of theta, to be equal to minus v squared, so that's 2.5 meters per second squared, divided by 2 times g, which is 9.8 meters per second squared, times delta x, which is 3 meters. And I can solve this problem numerically and find that theta is equal to 10.86 degrees. So the minimum value of the angle such that the block will slide along the plane and reach the bottom is 10.86 degrees.